All right, so the first question that is asked on sample problem A, it says, how many moles of lithium hydroxide? So which one, and it's kind of funny because I assume students understand names of compounds, and so I've been so used to doing this for so long that some people think this is lithium hydroxide. And so they'll start out with that. So if you don't know for sure, what do you have to do? You have to look up your polyatomic ions, and you have to make sure which one you have, because we have two lithium compounds. This is lithium carbonate, and this is lithium hydroxide. So the first thing you have to be aware of, and that's why we did those naming and writing formulas in such detail that you don't struggle with a word problem that says how many moles of lithium hydroxide. So what I do, and then this is just my method, and you don't have to use it. It's a little different in the book, but what I'll do is if I want to know how much of a certain reactant or product is, I'll put a line under that, reactant, and then I'll put a mole there, and I'm going to, that's a question mark, I'm going to try to solve for that. Right? So I need to find moles of that. It's an easy way to just say I need to find, if I wanted to find moles of CO2, I'd do a line under that and put moles under that. And I want to fill in that value. Okay? Now I have to know how much of a reactant or product that I have. Okay? So it says how many moles of lithium hydroxide are required to react with 20 moles of CO2. So here's carbon dioxide. So down there I'm going to put 20 moles, and that represents how much I have of CO2. All right. Now somebody could probably already tell me the answer. How much? 40. Right? How did you figure that out?
Multiply 20 by 2.
Okay. How did you know to multiply 20 by 2?
Because 1 mole of CO2 is equal to 20, so you just multiply 2 and 5.
Okay. So, but you use this ratio, right?
Yeah.
So, do you guys see the ratio 1 to 2? I have to keep that ratio the same with bigger numbers. So 1 to 2 is the same as 20 to 40.
Wait, how did you get 20?
Okay? That's in the problem. So the problem I'm looking at is on page 305. And it says how many moles of lithium hydroxide are required to react with 20 moles of CO2. Yep. Now, I'm not going to just leave it at that and then write in the answer and go on. Because the method of solving that you're going to have to do over and over and over again, so repetitive. You have to do this setup in every single problem. Every single problem you do in this chapter, I don't care what problem is, you have to do a mole-to-mole problem. Okay? So it is the very most basic, most important process of doing problems. And it looks really simple to begin with, but then when you start having different values you have to go through, then it's tougher to know where to place that ratio. So I'm going to put 20 moles of CO2, and then, guess what? Good old conversion. Then down here, what unit am I going to put? Moles of what? CO2. So I can cancel them out. All right, good. So then up above, what do I want to put? I'm trying to solve for this, right?
2.
So I'm not going to put a number in yet. I'm going to put moles of LiOH. Any questions? Now, where did those numbers... I gotta have to put numbers in here. Some students, they like to always put 1 mole because they're used to going grams to moles. Okay. But on this one, I'm going to look at my balanced equation, and that tells me what goes where. So what goes in front of CO2? 1. What goes in front of LiOH? 2. Multiply them out. 40 moles of LiOH. So I've solved for that. That would be 40. Okay? it's double. Question, so every time you do a problem that's a mole to mole, you got to look at your numbers in front of your balance equation. That tells you your recipe. Tells you how much you make, tells you how much you need. But you'll always be given a certain reactant or product in which to work with. Okay? So we'll do another example similar to that, and I'm going to have you guys turn over to page 306. 306. So I'm going to write this reaction out. We're not going to try to do too many of these where you have to do things that you learned last chapter. Okay, we're learning a new kind of setup, and so we're going to have you maybe bring that in later. All right. So we're going to look at problem number 2, and it says that KClO3 decomposes. And when it decomposes, it makes potassium chloride plus oxygen gas. We'll go ahead and balance that so that you don't have to worry about that part. So then, there's our balanced equation. All right? So, top of page 306, it says, how many moles of potassium chlorate? So which one am I trying to find? This one or this one? Which one's chlorate? First one, right? That's chloride. If you don't know, look it up. Cl's chloride. So we're going to go, I don't know how many moles of that, but I'm going to find out. All right? So I want to know how many moles of potassium chlorate it is required to produce 15 moles of O2. I need to make 15 moles. How much of this do I need to use to make 15 moles? So then what I'm going to do is take what I know, and then you guys fill in the rest. You go ahead and fill in the rest. Go ahead and do the final calculation. Now some of you can do it in your head, but there'll be some of these you're not going to be able to do in your head. So I understand this one and the one prior. Some of you guys can see the ratio and relationships. Okay? And I know the individuals that do this, they will not show work. They will just, the easy ones they'll get. And then when it comes to ones that are kind of goofy numbers that don't have those nice little relationships, they don't know how to proceed to do the problem. Okay? So I will encourage even those individuals that think they've got it figured out, they don't need to show anything, that's what happens later on. It gets more complicated, and then you get into problems, okay, that you can't solve. We are at the top of page 306, problem number 2. Problem number 2. Top of page 306, problem number 2. Okay? So what's the answer? 10. So 10 moles is the answer. Down here, what I'm going to do, now, I'm really disciplined about this because I want you to be disciplined. I could just start putting numbers in and just go. But all I'm going to do is I'm going to put moles of O2 down here, no number in there. And then up above, I'm going to put moles of KClO3. I haven't put any numbers in. At this point in time, I look at my numbers in my equation. I put 3. I put 2. Moles cancel out. I get 10 moles of KClO3. Questions?
It's a pretty easy concept.
Okay? Yeah, it's usually what I get, and then when I get to where we start grams, and using grams, and then going more steps, then it gets tougher. But it's, yeah. Okay, questions?
There you go.
15 times 2, 30, divided by 3. All right. Now, it doesn't get that much more difficult at this point in time because all we're going to do is introduce grams. And if I introduce grams, what are you going to have to do with those grams in which to do the problem? Convert it to what? Moles. Convert it to moles. Okay? That's all you have to do. And you've done that, those type of problems repetitively. Okay? What I want to do is now is look at sample problem C on page 307. Look at sample problem C on page 307. Okay? So you can read it, and then I'm going to show you the equation. In fact, we're going to do sample problem B. I'm sorry. Sample problem B on page 306. Sample problem B. You can go ahead and read that one now. This is the balanced equation for. You have to have an equation. You have to have it balanced. Okay? So every problem that you do, you've got to have a balanced equation. If there's numbers in front, you know that it's balanced. So in the assignment, they give you numbers in front. You go, oh, I don't have to balance. That's already balanced for me. Okay? Then I use those numbers to do my mole ratio. But if I'm given grams, or if I'm given moles, and I have to find grams, then I have to do two parts. All right? So I know I got 3 moles of water. Right? 3 moles of H2O. This stuff right here. Okay? And then what it's asking, what's the mass in grams of glucose produced? So here's glucose. So what I like doing is I like putting grams above. I like to separate the two. I like moles down below if I write them in. And up above, I just like put grams so that way I kind of separate the two. Now, to get grams, what do I need to do with this 3 moles to get to this point?
Converting the moles to grams.
I do, but before I go moles to grams, I can't go directly to grams.
You have to do each element, right?
Okay. Eventually, I've got to do each element. How do I get to grams of the glucose if I got 3 moles of water? Yeah.
Oh, I had a different question. I was just wondering why it isn't 6 moles
For which one?
for the bottom.
Okay. All right. This is the method I use. You guys don't have to do it.
I got it. It's right there.
Okay. All right. I just put what I know down below.
Yep.
Exactly what because what that does, it allows me to give me a map to get to here. I cannot go diagonal on my map. My directions say I can either go horizontal or vertical, but I can't go diagonal.
We gotta find how many moles are in.
Right, you got to find out how many moles of glucose. And we just did one of those problems. So you put 3 moles of H2O. My first step is to go from moles of H2O to what? Moles of glucose, right? Yes. So did we do one of those problems already? Moles, I told the other classes, moles is a translator. I know English. Josie, you know Spanish, but you don't know English. Okay? Hannah knows both. So I talked to Hannah so she can communicate to you. Yep, and you can communicate back. Okay? And she is like moles. She can translate through, and you've got to go through moles before you can go to grams. So down here, what number goes? Here. What goes here?
6.
6. What goes up here?
1.
1. Right? So where are we on our map?
We're right below the grams.
Right. We're at this point right now. If we would calculate, we'd get that value. So at that point, I need to do something you guys have done a lot of already. So what goes down here? Moles of what? Glucose. What goes up there? Grams of glucose.
Let's go. Let's go, boys.
Okay, so now I'm going from moles to grams. So down here, what number goes down here?
0.5.
Just one.
Why 1? Why would we choose 1?
Because it doesn't change. It's
Because
already one.
can we find the grams of 1 mole of this stuff? How you do it? You should know because you've done it.
Find the mass of the elements.
No? What do you do to find grams of 1 mole of C2H3H12O6? Find the molar mass of it. That's grams per mole. So 6 carbons, 6 times 12 is 72. 12 times 1 is 12. 6 times 16, 96. Add them all up, you get 180. 0.18.
Wait,
Okay, alright, just stop for a second. At this point you got moles. All you have to do then is convert moles to grams. You guys have done that over and over and over again. Okay? We get to this step and some people are like, I've never done that before. I've never found a molar mass before. I've never changed grams to moles. Okay?
so what is the number that you have for grams for C6H12O6?
180.18. Alright. So 3 divided by 6 is 0.5. 0.5 times 180 is your 90. So you got 90.09 or 90.1.
3 divided by 60.
Okay, 90.1 grams. Questions?
That's not that bad.
I'm just saying.
Okay, Ray.
Now, guys, they give you great detail in their examples. So you guys do have books. You can look at examples they have. And they give tremendous detail on showing those steps and how to analyze that. And you can look at that over again. So I got one more to do with you. And that's on page 309. Turn to page 309. Alright guys, this is a balanced equation. They have just the unbalanced. You'd have to balance it. So I balanced it for you so you don't have to worry about that. 4, 5, 4, 6 going across. The question is stating, we're going to do part B. The question says, how many moles of water? Part B, it says, how many moles of water? They give you so much of a reactant. They say, you know what? We're going to give you 824 grams of ammonia. So 824 grams. We can't go grams to moles directly. You have to go through your translator. And your translator is moles. Okay? So we're going to go 824 grams of NH3. We follow our units. Grams of NH3 automatically go down here. Then up here should go, no, moles of what?
NH3.
NH3. Alright, here's a problem. I'll show you what students do on this. They'll want to put, down here, they'll figure the weight right, and they'll go 1 nitrogen, 3 hydrogen, 17.04. I've got that. And guess what they'll write up here? That's wrong.
What?
They'll write 4.
Why? Oh, no, that's.
Because this is how many grams are for what?
1
mole. Alright, so I'm going to give you something to remember. Hopefully you can remember it. Every time you got grams to moles, it's always 1 mole. Okay? If it's mole to mole, like mole to mole in a setup, then it's these numbers. It's the numbers in your balanced equation. Okay, so we got moles of NH3. We've got an easy step, the last one, because all we have to do is copy our units. They're copied. I'm not putting a unit in there yet. And so we're at the first point, we're here. So we're at moles of NH3 after this first step. And now we've got to go over there. So then what goes up here?
6.
Okay, I want just the units first. Moles of H2O. So then what numbers go in there? 4 and 6. Okay, that's my math. I just do this. I had a student a long time ago that said it really helped him. And, I've always remembered, he said he went to college and he remembered going through that process of knowing where you're at, where you need to go. It's kind of a map. You don't get lost. I can't go diagonal. I always got to go vertical or horizontal depending upon, where I want to end up. So then I do that. I calculate my answer. And when I calculate my answer for that one, it's 72.5. Okay? Students work these problems out. One thing they do wrong, they don't label. Okay? They choose not to label, and then I'm not going to feel sorry for them in the future when I've been telling them over and over again they have to do it. Okay? You got to be detailed.
Is it 72.5 or 7?
Well, that's what it said in the book.
72.5.
72.5 is in the book. Okay. The assignment is page 890. This is due on Monday.
And the notes are. Yeah. Do you want that?
No, this. I'm going to have you hand this in because I want to see your work. Okay? But I'm going to add 2 more problems to this tomorrow. So when you come back tomorrow, we'll give you how to do the last 2. But if you want to get it all done, you should be able to do all these problems. By tomorrow, you'd only have 2 problems to do. Yes?
Can I have that? I'm not.
Yep, I'm going to give that before you go. Yep, if you're going to be gone, I'll tell you what problems you'll have to do. Okay?
I don't know why I did air quotes.
All right, I'm going to go ahead and write this. This is being recorded, so I'm going to go ahead and write this up.
He didn't even believe himself. Yes, but the speech is real. Yes, it is. It's a swarm. The speech is a swarm, really.
Oh my god. Are you not serious?
It's not. It's a good funny meme. Speech is a sport.